I'm actually here to talk a little bit about what we do with HPC, and from a commercial point of view, we actually make money on it, so we kind of sell it to our customers. And how do we do that? What have we done besides, well, obviously we don't have our own, well, we do that too, have our own HPC cluster, but we use mostly cloud-based HPC. So, to start with, I need to give you a quick introduction to Cegal, so that you know a little bit more about the background. We are a global tech powerhouse, is what we like to identify ourselves as, and we specialize in energy. The history is kind of oil and gas oriented, which some of you might see during some of the slides coming up. But we have a few years now where we have also been into other fields within the energy sector, like electricity, for instance. So this is just a quick slide to show that we have a global reach. We well, have customers not all over the world, but almost. You might even recognize some of our customers you see on the bottom here. We think we are a company just the right size. We are big enough to take on the big customers and small enough to actually be easy to work with. Yeah. And okay, so what do? We have three different sort of main areas where we offer our services. We do cloud operations, and of course we have a services department which have a lot of consultants out in the field, and also of course software. We have been started like a traditional IT company, and we have been developing sort of in these three directions. All we do is based on business value. We, even of course in the HPC area, we try to see what can we contribute, how can we contribute to giving the customers more business value. So well, I'm not going to go through all these percentages and numbers, but as you can see, they all indicate that we try to give the customers more efficiency, give them more, sort of to earn more money, basically. So as the bottom line there, software, we do develop a lot of software in Cegal, and we have call it a umbrella kind of an approach, where we have a system or a line of products which is called Cetegra. It is basically a platform for administrating all kinds of different parts, like users or applications, offering all the company's applications in whatever unit they want to use, like a phone or a PC or web, whatever, and we make it available for them. We take care of the application management. We do develop different things like high-performance desktop solutions, all kinds of stuff, but I'm here to talk about the HPC product. So, to dive into that, I think that we should probably bring up an example, and I think it's important to mention that we focus on customers with a high demand of uptime, and they are willing to pay a lot for that, which is basically why we offer our solutions on the perhaps more the expensive side of the cloud offerings, like Azure and others as well. And we also have a cooperation with Oracle, I'll come back to that later. But the image you see on the right side is actually from a seismic interpretation, which is one of the fields, at least in the oil and gas industry, that requires a huge amount of compute. So what have we done to give these customers something more than just setting up a cluster? Because pretty much many of them could probably do that themselves. In Azure, there are a lot of help tools that makes that possible. But we spin up the cluster. We do that by automation, and we use Microsoft's own Cycle Cloud when we work with Azure to administrate the cluster. And then we, of course, use this normal things like the scheduler and stuff. But we do put a lot of effort into showing the customer what is going on the cluster. What jobs are running there? How does it sort of come out when it comes to node utilization, stuff like that? Yeah, and we have of course, all the benefits of a cloud-based cluster, like scalability and stuff like that. We do have an AI focus, but I think it's important to mention that in this field, we see that we struggle a bit with the AI development because of the users, the customers, are not that willing to share their data. So we have a sort of a challenge there to actually get access to the data and to train AI for this. And one thing that the energy business really want is to see or to predict cost. They want to have a really large, for instance, a simulation, and they want to start that, but before they start it, they want to know how much would this cost. And that is, until now, it's the only way of finding out is to run the simulation. So, anyway, so I'm going to show you a few screenshots here. These are just like a summary of them. We have some reports, a dashboard, and of course a safety net that we have built around it. And this is just the first one here is just a dashboard. It's just pretty much like what is the status of the cluster, which jobs are running, what queues do we actually have access to, or the sync window. We sync with Azure every minute, so it's kind of live. And then we have a lot of reports that we have made to give the customer insight, because almost all our customers are asking for deep insight. What is going on? How can we utilize the system better? How can we save cost? How can we make sure that we sort of make use of all the machinery that we have available, and so on? So pretty much all of these examples here are just different ways of displaying that kind of information. And all of them are presented in a way that it is possible to sort of dive into details and see even more what is going on. And of course, also we do the same thing with cost. You can drill down and find out how much does each application cost you, how much does, even for those who are thinking about GDPR, we do offer the possibility of actually showing how much each employee is costing. Some companies are asking for that. Of course, this makes it very clear to them how do they exploit the system they have access to. And of course, we do export, like tagging the projects, the jobs for external use. So I mentioned the safety net. So what we have done here is to put in a system just to put in some warning, so that if when you have you can put in like a limit of how much money would you have a budget for this project, and during, for instance, a month. And then if you pass that limit, you'll get a warning, and you can have as many as you like of those warnings set up. We do the same thing with, we also have a discount monitor where we keep track of if a machine virtual machine is offered at a lower price. You can actually go in and order that instead of the one you're using if it's compatible. And we do have a job monitor that makes at least the users make them able to put in like warning if a job takes longer than expected. They could have a warning by SMS or email. For instance, if a job takes a couple of days, they don't have to sit by their desk. They can just get a warning that they need to go in and check. Okay, we're getting towards the end here, but this is just an example of how does it look? How does it look when you submit a job to a cluster like this? This application here is run on a VDI directly to the cloud, and it is T-Navigator. I don't know if you're familiar with that, but it's a geotechnical software. It's kind of a platform that you could have different modules, and in this case, it's a reservoir simulation. There's one, and well, that didn't work well. I'm not sure how to start the movie here. Do you have any idea? Should be possible to, yeah. I don't have that, but I have 2 buttons on the remote, so it's either back or forward, and forward doesn't work, so let's just skip it. It's just an animation of what it looks like, and if you want to see it, you can join us out in the booth in the hallway afterwards. I'll just move on to the last couple of slides, because I think it's also, I've been talking, well, mostly about Azure now, but also I think it's important to mention that we do work with Oracle. And a few takeaway points regarding Oracle is that they are very cost effective, which is to some would be, I think, interesting. Also, they have a lot of machines available, so it's kind of a, scalability is of interest there. And also, one thing that they are very good at is the sovereign kind of thing, that where you know where your data are. So, the last one here, to all of you that was actually hoping that I would dive into this and give detailed explanation here, I'm sorry to disappoint you. I will definitely not, but it's just an image to show that they really have their stuff in place, and they are very tight connection with developers, so they would have their hardware very early, and yeah. That's about it from me.
Thank you, Glenn.